Hi, hello, welcome to Vision classes. Today we are gonna look at one of the interesting question from May-June 2020 physics paper. Okay, we'll directly move towards the question. Now, this is question that we have to discuss today. So it's a question from your current of electricity chapter. Okay, this is fifth question. Look at this one. Metal wire is used to connect the power supply to a lamp. The wire has a total resistance of 3.4 ohm, and the metal has a resistivity rho. It is equal to 2.6 times 10 raised to negative 8 ohm meter, and total length of wire is actually L is equal to 59 meter. Now, in a first part, what we have to find out or show that here wire has a cross-sectional area 4.5 times 10 raised to negative 7 meter square. So here our formula is resistance of wire. Let's say this is a wire, okay, and has a cross-sectional area A, resistance or resistivity rho, and length, let's say L. Okay, so R is equal to resistance is equal to rho L over A. Because we have to find out the area, we have to rearrange the terms, right? So A is equal to rho L over R. So put out the all values, use your calci and find out. I think so. Look at here, rho is 2.6 times 10 raised to negative 8. Keep as it is, and times L 59 for 3.4. So you will get 45.12 times 10 raised to negative 8. So just switch 1 point towards left, it will be 4.5 times 10 raised to negative 8 meter square area we get, right? So which is equal to this value. So see here, in this question, the marks are divided for your formula, then steps and calculation. Okay, so if you got the correct calculation, you will get out marks. Then nextly, potential difference across the total length of wire is 1.8 volt. So calculate the current in the wire. So already we know the resistance. Resistance is given 3.4 ohm, right? So to calculate the current, we have a formula. I is equal to V over R, voltage over R. So voltage we have 1.8 or 3.4, right? So you will get easily direct answer 1.8 or 3.4, which is equal to 0.53 ampere. Okay, ampere already written, so you can just directly mention here 0.3 ampere current. Got it? Now, third part, then nextly here, the number density of free electron in the wire is 6.1 times 10 raised to 10 raised to 28 meter raised to negative 3. Okay, this is just a density is given, right? And calculate the average drift speed of a free electron in the wire. I hope you know that I is equal to a n times v times q is a formula to calculate the average drift speed. Average drift speed means here v velocity we have to calculate. So you can rearrange the formula I over a times n times q. So everything is given here. So number density already here we have n is equal to 6.1 times 10 raised to 28 meter raised to negative 3. Then q is also known here, right? Then we know the current as well, I 0.53. So just to put out the all values, 0.53, or A is actually cross-sectional area, 4.5 times 10 raised to negative 7. We got early, in a first part right here. Okay, then times 10 density 6.1 times 10 raised to 28. Then Q charges, actually it's a 1.6 times 10 raised to negative 19. Okay, charge on the electron actually. So if you calculate this one, you will get, okay, stop this video and just calculate this one. It's a 0.53 or 4.5 times 6.1 times 1.6 times 10 raised to 28 times 10 raised to negative 19. So you will get around 1.2 times 10 raised to negative 4 meter per second. Okay, velocity, and this is the average speed, 1.2 times 10 raised to negative 4. Got it? Yes. Then nextly, look at this B part. A different wire carries the current. A wire has a part that is thinner than the rest of the wire, as shown in here figure. Look at this one, wire, thinner part, and again wire, right? Okay, so this is just a part of a wire, right? Now we'll go through the subsequent questions. Question 1 says that state and explain the quantitatively how the average drift speed of a free electron in the thinner part compares with the rest of the wire. Means generally it asks about just how if cross-sectional area changes, drift speed, average drift speed changes. So we have a relation right here. We actually rearranged the term and found out the formula. So V is equal to I over A times N times Q, right? So so therefore you can say that average drift speed is inversely proportional to the area. So you can simply here add like this one, as area increases, drift speed decreases. Okay, and area decreases, velocity, average drift speed increases. So inverse relation is there. This is for this two step you will get the marks. Okay, so this is how you can put out the answer for this question. Now second part is that state and explain whether power dissipated in the thinner part is same or less or more in than the power dissipated in the equal length of rest of the wire. Now I hope you know the relation between the power and the directly resistance. Okay, power and resistance. So P is equal to I square R, dissipated in the thinner part, or just to simply ask the relation between the power and the area, how they are correlated. So instead of this I, you can put out the values. Okay, so or simply instead of this R, you can put out I is I square times rho L over A. So this is a relation. So you get P inversely proportional to 1 upon A, right? 1 over A. So area is inversely proportional to power, and you can say that means as area increases, power dissipation decreases. As area decreases, power dissipation increases. Okay, so inverse relation. So right. So here you can simply add A is less, P more. Okay, P more. So this is how you can add simply. So for this step, you will get the marks. Fine. Simply we have to put out the relation between the power and area. Now the next C part, three resistors have a resistance 180 ohm, 90 ohm, 30 ohm. Sketch the diagram showing how two of these three resistors may be connected together to give the combined resistance of 60 ohm between the terminal. At which case, either parallel or series case, at which case you will get the 60 ohm resistance. So here, if you place them as series case, any of them, you will not get the 60. So to get the 60, you need a parallel combination, first thing. Okay, now which two resistance you have to pick? Look at this one. If you pick 90-30, you will not get 60. Okay, so you have to pick 180 and 90 so that you will get, and place them in the parallel combination so that you will get 60 ohm, right? 60 ohm, 180 actually. This one is 180 and this one is 90 ohm. Okay, and if you calculate the resultant resistance through this formula, 1 over Rp is equal to 1 upon R1 plus 1 upon 1 over R2. Okay, so you get the resistance Rp, resultant resistance across this circuit will be equal to 60. You can calculate it. Okay, because it's just a simply LCM of a two resistance, isn't it? Basic math. Fine. Then nextly, last part. So potential divider circuit, which is given here, provided, sorry, the potential divider circuit is produced by connecting three resistors to the battery of electromotive force 12 volt, the negligible internal resistance. The potential divider circuit provide output potential difference of 8 volt. Now means you have to just here label the resistance of all the three resistors and potential difference. That is what we have to show in this figure. Okay, so here we know that means so in the parallel connection, we have to put here 180 ohm, 90 ohm, like this one, and then left with 30 ohm, right? Okay, and we have to show even V out 8 volt, okay, across the two resistors in the parallel, isn't it? Here means 8 volt actually. We can mark here, fine, or label here V out, okay, across the parallel combination. Fine. Yes, look at this one. What it says is that means generally, so in a first case, we found out the cross-sectional area, then potential difference in the across the length of the wire, right? So we have to calculate actually here current, then we in a third part we calculated average drift speed, right? Then the different wire carries the current, fine. So thinner as well as here the wire part, fine. Then nextly we have to state and explain actually a relation between the drift speed and the area. Okay, it's an inverse relation. Then we have to compare the power and the area. So if area is less, power is more. If area is more, power is less. Okay, and then here we have to show the at what probable combination we get the 60 ohm resistance out of this given three resistors, 180 ohm, 90 ohm and 30 ohm. Okay, and we have to, in this case at the last, we have to label the resistance and potential difference. Okay, that's it. I have left contact number for a student who want to get connected with our tutoring teaching. So that's it. If you like this video, share with your friend. Bye bye.